Welcome to G Fun Facts Online. Today, we're talking about an all-seeing eye in the sky, a revolutionary tool that is changing how we understand our home planet. It's called NISAR, and it's not just another satellite. It's a landmark collaboration between NASA and the Indian Space Research Organization, ISRO, designed to watch the Earth breathe, shift, and change in ways we've never seen before. Launched on July 30th, 2025 from India, this mission represents a monumental leap in our ability to monitor our world. With a price tag of over $1.5 billion, it's one of the most ambitious Earth-observing projects ever undertaken, and its goal is simple yet profound: to see the unseen. From the subtle rise and fall of the ground before an earthquake to the slow, relentless melt of polar ice, NISAR is set to provide an unprecedented, dynamic picture of Earth. So how does this incredible machine work, and what will it mean for science, safety, and our future? Let's dive in. At the heart of the NISAR mission is its groundbreaking science instrument, a dual-frequency synthetic aperture radar, or SAR. Now, you might be familiar with satellites that take pictures, like the ones you see on Google Maps. Those are optical satellites, and they work like a camera, needing light and clear skies. But what happens when it's cloudy or dark? They're effectively blind. This is where radar comes in. SAR doesn't take pictures with light. It sends out its own microwave pulses towards the Earth's surface and then listens for the echoes that bounce back. Because it provides its own illumination, it can see perfectly, day or night. And since radar waves can slice right through clouds, rain, and fog, it gives us an uninterrupted, all-weather view of our planet. This is a huge advantage for continuous monitoring. But the real genius of NISAR is that it doesn't just have one radar. It has two. This is the first time a satellite will systematically map our planet using two different radar frequencies simultaneously. Think of it like having two pairs of eyes with complementary superpowers. NASA provided the L-band radar, and ISRO provided the S-band radar. The L-band uses a longer wavelength, about 24 centimeters, or roughly the length of a dinner plate. This longer wave is a master of penetration. It can see through dense forest canopies, allowing scientists to measure the structure of the forest floor and tree trunks. This is absolutely critical for accurately measuring forest biomass, how much carbon is stored in our forests, and for spotting changes on the ground that would otherwise be completely hidden from view. Then there's the S-band radar from ISRO. It uses a shorter wavelength of about 12 centimeters. This shorter wave is more sensitive to smaller, lighter things. It's perfect for looking at the canopies of crops and lighter vegetation. This makes it an ideal tool for monitoring agricultural fields, tracking how crops are growing, and assessing the moisture in the soil. By combining the data from both the L-band and the S-band, scientists get a far more detailed and complete picture than either could provide alone. They can distinguish between different types of vegetation, understand the complex three-dimensional structure of a forest, and measure incredibly subtle changes in the ground with astonishing precision, down to a fraction of an inch. But having these powerful radar eyes is only half the battle. The Earth is vast. To map it effectively, you need to cover a lot of ground, and you need to do it quickly and in high detail. This is where another piece of revolutionary technology comes in: the sweep SAR technique. This is the first time this method has been used on a space mission. To understand it, picture the satellite's antenna. NISAR carries a massive 12-meter or 39-foot deployable mesh antenna. It's one of the largest of its kind ever sent to space. When NISAR sends out its radar pulse, it uses the whole antenna to send out a broad beam, illuminating a huge strip of land on the ground, about 240 kilometers, or 150 miles wide. That's like seeing from Los Angeles to San Diego in a single pass. But the clever part is how it listens. As the echoes return from the ground, the radar feed sweeps its listening beam electronically across that massive antenna. This sweeping motion allows it to capture signals from different parts of that wide swath in rapid succession. This data is then processed to create a seamless, high-resolution image. This sweep-SAR technique is a technological marvel. It allows NISAR to achieve its ambitious goal of mapping nearly the entire land and ice surfaces of the Earth every 12 days. And because the satellite's orbits overlap, most areas will actually be imaged even more frequently, on average every 6 days. This rapid revisit time is a complete game-changer for monitoring dynamic processes. We're moving from a series of static snapshots to a continuous high-definition movie of our planet in motion. Now, let's get to the most important part. What does all this amazing technology actually do for us? The sheer volume of data NISAR generates is mind-boggling, a staggering 80 terabytes per day. This flood of information will touch almost every aspect of our lives, from predicting disasters to ensuring we have enough food to eat. First, let's talk about natural disasters. NISAR's ability to detect tiny movements of the Earth's crust is going to revolutionize how we understand and respond to earthquakes, volcanoes, and landslides. For volcanoes, the satellite can spot the subtle swelling of the ground that often happens when magma moves beneath the surface. This could provide crucial early warnings, giving communities precious time to prepare and evacuate. This is especially vital for the hundreds of volcanoes around the world that have little to no ground-based monitoring. In earthquake zones, NISAR will track the slow, imperceptible buildup of strain along fault lines. While it won't predict the exact time and place of a quake, this data helps scientists better assess earthquake hazards and understand where risks are accumulating. And after a quake strikes, the satellite's data will provide rapid and detailed maps of how the land has deformed, which can be used to assess damage to buildings and infrastructure, guiding emergency response teams to where they are needed most. Similarly, by monitoring the slow creep of hillsides, NISAR can help identify areas at high risk of landslides, potentially saving lives and property. Beyond sudden disasters, NISAR is poised to become an essential tool for agriculture and water management. The S-band radar, with its sensitivity to crops, will provide detailed information on crop health, growth stages, and acreage. This helps governments and organizations improve yield forecasts and strengthen global food security. But perhaps even more critically, NISAR can measure soil moisture with high resolution, right down to the farm level. Researchers at Michigan State University have even developed a specific algorithm to turn NISAR data into detailed soil moisture maps. For farmers, especially in drought-prone regions, this information is invaluable. It allows for optimized irrigation, saving water, and improving crop yields. For governments, it helps in managing regional water resources and issuing early warnings for agricultural droughts. This isn't just about better farming. It's about building resilience in our food systems in the face of a changing climate. And speaking of climate change, NISAR will provide a continuous health check on our planet's vital ecosystems. Its L-band radar, which can see through forest canopies, will allow scientists to create the most accurate maps of forest biomass ever produced. This helps us understand the crucial role forests play in absorbing carbon dioxide from the atmosphere. It will also track deforestation and forest degradation with unprecedented accuracy, supporting conservation efforts worldwide. The mission will also keep a close watch on the world's wetlands, which are critical for biodiversity and water quality, and monitor the thawing of permafrost in the Arctic. As permafrost thaws, it releases huge amounts of trapped greenhouse gases, like methane and carbon dioxide, so tracking this process is essential for our climate models. The Earth's frozen regions, or the cryosphere, are also in NISAR's sights. These are some of the most sensitive indicators of climate change. The satellite will provide a detailed, dynamic picture of the world's ice sheets, glaciers, and sea ice. It will measure the flow rates of glaciers, track the melting of the massive ice sheets in Greenland and Antarctica, and monitor changes in sea ice extent. This data is absolutely crucial for understanding the drivers of sea level rise and for improving the models that predict our future climate. Finally, the same technology that spots a volcano swelling can also protect our cities and infrastructure. NISAR can detect subsidence, the gradual sinking of the ground in urban areas, which can damage buildings, roads, and pipes. It can also monitor the stability of critical infrastructure like dams, levees, and bridges, identifying subtle movements that might indicate a potential failure. This gives engineers and city planners the information they need to take preventative action and enhance public safety. One of the most significant aspects of the NISAR mission is its radical commitment to open data. All data from both the NASA and ISRO radars is being made freely and openly available to the public, often within just 1 to 2 days of being collected. In emergencies, that turnaround will be even faster. This democratizes access to this incredibly valuable information. It empowers scientists, governments, businesses, and even citizen scientists around the world to use it for research, for innovation, and for making better decisions. This is expected to trigger a wave of new scientific discoveries and applications we can only begin to imagine today. The mission itself stands as a testament to the power of international collaboration. The partnership between NASA and ISRO was the key that unlocked this ambitious project, with each agency contributing its unique expertise and technology. It sets a powerful precedent for how nations can work together to tackle global challenges. As NISAR continues its mission, it is creating a time-lapse movie of our planet's surface, revealing the intricate and interconnected processes that shape our world in stunning detail. From the imperceptible creep of tectonic plates to the seasonal rhythm of plant growth, NISAR's all-seeing eye is giving us a deeper and more dynamic understanding of our home. This isn't just about collecting data for the sake of science. It's about generating actionable information to help us address the most pressing challenges of our time, from climate change and natural disasters to food and water security. The legacy of NISAR will be seen in the new insights it provides, the innovations it inspires, and the more sustainable and resilient future it helps us to build. The future of Earth observation is here, and it is watching over us all. Thanks for tuning in to Fun Facts Online.